Hello, my name is Nick Breen, and my thesis is titled Source Location of Subsonic and Supersonic Jets of Various Geometries via Acoustic Beamforming. In the context of aeroacoustics, source location refers to a methodology that allows the identification of sources of noise of various frequencies in the noise-producing region of the flow. The need to understand and reduce aircraft emissions has led numerous researchers over the years to apply different source location techniques to jet mixing noise. Accurate knowledge of jet noise source location is critical for applications such as correcting near-field jet data, as well as applying corrections for flight effects to jet noise data. In terms of literature, there have been lots of studies examining subsonic noise source distributions. However, there is a lack of literature on supersonic and twin jet noise source distributions. I use acoustic beamforming as my source location method of choice in my research because it is a very convenient technique. You can use an acoustic beamformer to locate noise sources by examining the signals received at each microphone in an array. The signals at each microphone are delayed by a little bit differently for each microphone, and their levels are a little different. You can correlate these differences to different regions in space, which allow you to locate the noise sources. Beamforming is a convenient source location technique because it allows for very rapid acquisition of data. You don't need to move the array around. Once you have it, you can acquire your data. In my work, I examined the source locations, the noise source distributions of subsonic jets, supersonic jets, and twin jets. In subsonic jets, like the one I drew here, the noise is produced in the mixing layer of the jet. The mixing layer starts very small near the nozzle exit and grows as you move downstream. In the mixing layer, there are these turbulent structures that produce the noise of the jet. They are very small, and then they grow. When they're small, they produce high-frequency noise, and when they're larger, they produce lower-frequency noise. This results in a noise source distribution where you have high frequency near the nozzle exit and low frequency further downstream. As you move to supersonic nozzles, or jets, you still have jet mixing noise, but now you have shocks in the jet. As the turbulent structures in the mixing layer pass over the peaks, or the points of the shock cells, it causes the tips to oscillate and produce noise at all frequencies. This results in a noise source distribution that looks very similar to the subsonic. However, it also has discrete sources at the tips of the shock cells in the jet. In the future, data like this will allow researchers to develop models for supersonic jets, which will allow for better correcting of data and designs of nozzles. Unfortunately, I was only able to present just a small fraction of what's in my overall thesis here today. I thank you for your time, and I recommend you go out and look at my thesis for a better idea of what I researched. Thank you.